Hello YouTubers! If you are interested in learning the basics of SQL Server, then this is the video for you. In just 1 hour, you'll have mastered one of the fundamental parts of T-SQL. I'm Phillip Burton from SQL Server 101.com. I'm the author of 5 best-selling SQL Server courses on Udemy, and I want to show you how to use SQL. In this video, we'll be going through the select statement. That's how you retrieve data from SQL Server. And its 6 main clauses: select, from, where, group by, having and order by. You'll also find out the one thing you need for your next job interview and how to remember it easily. We'll also be looking at how to join 2 tables together, how to create views and procedures, and how to connect SQL Server to Excel. Do you want to learn SQL Server quickly? Then let's start.
Well, what we need to start with is a program called SQL Server Management Studio. And you can see the quickest way that I found it on my system is just typing SSMS. So if I now run this program, so here comes SQL Server Management Studio. This is where you do a lot of work with T-SQL, which is your standard SQL Server code, the select statement, which is what we'll be looking at in the next few videos. This is also where we do DBA, Database Administration. So first of all, we have connect to a server. Now your server name will be completely different, but what's important is it says server type, database engine, server name, whatever the server name you've installed, and authentication, Windows authentication. And I just click connect. I ignore all the other options. So hopefully you've now found on your computer SQL Server Management Studio. You might have to search for it, especially if you've got an older version of Windows. Now, just in case you got to this screen, you click connect and maybe server name was blank. If server name is blank, then my suggestion is to put a period, a full stop, a dot as your server name, and that will allow you to connect to your local server. But generally, just accept whatever is there as your default. Obviously, if you are connecting to a corporate machine, then some server that's already been installed that's worth tens of thousands of dollars, then use whatever credentials you are given by your system administrator. So this is SSMS, SQL Server Management Studios, and let's just have a look around it. First of all, we have an Object Explorer. Now, if you don't see this Object Explorer, if it's disappeared, then go to View and Object Explorer. Now, this contains all of the objects that we are going to be using in this T-SQL and in the DBA section of this course. So we start off with databases. And if I expand that, then we have system databases and any databases that may have previously been installed. You can see that I've got a few databases installed. But we're going to ignore all of my existing databases and concentrate on a new database. First of all, what is a database? A database is an object, a container that can hold other objects. It can hold data, it can hold queries, it can hold procedures, and in this course, we're going to make all of those. So first of all, we need a database container. So what I'm going to do is right and click on the word databases and go to New Database. Now we can call this database almost anything we want within reason. So I'm going to call it my first database without any spaces. So I'm going to leave everything else as it is. This is just a test environment. I don't need to concentrate on any of these tabs or other options. They get really complicated very quickly. So let's just ignore that and just click OK. So once we've done this, in the Object Explorer, the phrase my first database has appeared. It's right here. Now, if I expand this new database, we've got tables, views, which hold queries. And in programmability, we've got stored procedures, and we'll be concentrating on these later. Within tables, we have got system tables. Within views, we've got system views. And there's actually quite a lot of them, to be honest. So all of this is just the outline of our database. It doesn't actually contain any data. So in the next video, we are going to create a table and we're going to populate it. We're going to add some data into it. Right, so the next thing we're going to do is we're going to create a table. So a table stores data. So what sort of table am I going to create? Well, what I'm going to do, I've got some previously created data here, and this is a purchase system. So in my purchase number 1, I bought 4 of product number 1 at a cost of $50.26, totaling $201.04. In my purchase order 2, then I bought 3 numbers 359 and 3 of 360s and so forth. So a perfectly ordinary transaction table. So I'm going to create it. I'm going to leave it on screen so we can have a look at it while we create the table. So to create the table, I'm going to right and click on tables and go new table. Again, there's an awful lot of detail that we couldn't look at, but we're just going to look at very simplistic, very easy to create things. So click new table. And here it says, well, what columns are you going to create? So I want a column called purchase order ID. And I want another one called order quantity. I want product ID, unit price, and line total. Now there is another thing that we have to specify at the same time. What type of column is this? Or more accurately, what sort of data do we want to store in the column? Now you can see that we've got various choices, including dates, time, text, though in reality the one that I use the most of the time is called a varchar, a variable character. And then we've got things like integer. Integers are whole numbers like 1, 2, 3 instead of 1.5. So this is when we really need to look at the data that we've got and decide what sort of column we want. And hopefully you can see that the first 3 columns can all be integers. They're all whole numbers. So let's change them to ints, int. Now these last 2 contain, well, money essentially. And so what I'm going to do is int would not be good enough, because if I put $50.26 into an int column, then it will truncate it to $50. So I would have a certain lack of accuracy. So instead, what I'm going to do with all of these is I'm going to put it into the money data type. There are many other different types I could use, but just for now, we're going to use int for integers and money for floating point numbers. So now I've created it, I'll press, well, what do I do? Well, I can press the save table here, or I can close this window. So let's click save. Either way, we'll get this choose a name. So what name am I going to call this? I'm going to call this transactions. So click OK and close this. And we'll go back to our Object Explorer, and you can see that the transactions table is where exactly? Now, one of the things about Object Explorer is that it doesn't automatically update after you have created a new object. The only exception for this is a database that you have created or attached. So if you've created a new object, be this a table, a view, a procedure, or anything else, and you want it to appear, then we need to click on the refresh icon. So now we can see that we have our transactions table. DBO, database owner, dot transactions. Every table will have something before this dot, and that is called a schema. But in this case, it doesn't really matter what the schema is. So in the next video, we're going to populate it. We're going to add some data to this table, and then we're going to retrieve it. So what we're going to do now we have our very first table, is we're going to populate it. We're going to add all of this data. So I'll just click on the first cell, not in the headers, but row A2, and scroll all the way down to the last cell, and then I'll hold down Shift, and that then highlights from A2 to E8846. So I'm going to populate this. I'm going to copy this into transactions table. But how do I do that? Well, one easy way is to right and click on the transaction table and go to Edit Top 200 Rows. Now it might seem a bit odd that I've asked to edit rows when we want to add rows, but the good thing about Edit Top 200 Rows is that we have a 201st row, or in this reality just one row because we don't have any data, where we can add new data. So what I'm going to do is I'm going to click on that, this little bit on the left hand side, right and click and go to paste. I could just use Control and V as well. Now you'll see it's starting getting populated, and at the bottom you'll see eventually the row numbers go up. So it goes up bit by bit. So this operation will probably take a minute and a half. So I'm just going to pause the video and wait until all 8,000 rows have been added. Right, so now you can see all 8,846 rows, 45 rows have been added. Now, as we're still in this edit stage, we could, if we wanted to, edit away. So in other words, I could change this from $45 to $46 and back again. Now, how can we retrieve that information? Well, this is the basic essence of this part of the course. Now, first of all, in this video, I'm going to show you a very quick way, and then I'll show you how to do it a bit more properly. If I right and click on this transactions table, I can not just edit the top 200 rows, but I can select the top 1000 rows. And let's just click on edit top 200 rows just to see what happens. So now you can see there are the first 200 rows there. But instead of using this read-write capacity to edit top 200 rows, I just want to read the top 1000 rows. So I'll click on this, and you can see a new query window opens, and here is the first 1000 rows. But hang on, I've got more than 1000, I've got 8,845. How can I change this from the top 1000 rows to the top 10,000 rows? Well, that's easy. Just add another 0. And to rerun it, I click on this execute, and I can also press F5. So now you can see it's bringing back 8,845 rows. So in these last few videos, what I have done, and what hopefully you have done if you have been following along, is opened up SQL Server Management Studio, created a database, created a table, added data to that table, and now we've retrieved it again. So in the next few videos, we're going to be having a look at this select statement in a bit more detail. The reason for this is that if you want to have any sort of job involving SQL Server, you are going to have to be reasonably competent. You're going to have to know off the top of your head how to be able to construct your very own select statements without using this GUI, this graphical user interface. That's not to say that you can't ever use it, but suppose you were going to a new job and they were going to test how well you can do SQL Server. Well, what often happens is you are asked to just type some SQL code without going into SQL Server Management Studio. You're given a Word document and you've been asked, how do you do this? And you've got to construct your own code. So in the next video, we're going to create our own select query. It's going to be a very basic one, but we're going to build it up bit by bit. So in this video, we're going to create our very own query. So I'm just going to close this existing query window and I'm going to click up here on New Query. So this gives me a completely blank window. Now, a word of warning. There is more than one database, or there are more than one database in my particular instance. And it's not just the database, as you can see, there are also 4 visible system databases. There's also a hidden one as well. How does a computer know that I want to query a table in the my first database as opposed to, say, the master database? And the answer lies up here. This shows which database this particular query window is currently using. Now, make sure you have the right database that you're going to be using. If you want to change the database, so let's say I'm in the master database and I want to go to the my first database, there's a very simple command called use. So use, and this is when I drag my first database from the Object Explorer to the query window. Saves a lot of time. And then I press enter or the carriage routine, and then I go. If I execute this, that changes my database to my first database. So that's just a tip. Make sure you're in the right database. So I can keep this or I can get rid of it and continue. So what I want to do, first of all, is I want to retrieve the information that I've just added into the transactions table. Now I do this by writing a select statement. But first of all, let's just have a look at the computer and see what's actually happening. Is SQL Server running? The answer is yes, but in the background. The foreground, this SQL Server Management Studio, isn't actually doing anything. Pieces of code that you can write as many pieces of code as you want, but they'll only run when you click on execute or press F5. So, select. What is the select statement? Well, in other programming languages, we would use the word print. So that's essentially what select does. It prints not to pieces of paper, but it prints down here to this place where we've currently got the tab messages because we've just executed this use command. Now the select statement is built up of 6 main clauses. Select, from, where, group by, having, and order by. And we'll be looking at each of these in turn. So select statement is built up of clauses. So we're going to start off with the select clause, which is an essential part of the select statement. Now I don't actually have to be querying databases to begin with. I could just say select 1 plus 1. So imagine this programming language where I use the word print. So print 1 plus 1. I click execute. And there we have our answer 2. And let's have a look at the messages that came up. 1 row affected. So the word affected means it's either been printed out in a tab down here or it's been stored internally. It doesn't actually mean that there is any modification to the data. Now note that it has a column name of no column name, and that's because we've not given it a column name. So to give it a column name, what I'm going to do is type the word as and then give it a column name like result. So if I execute this, you can see that we've now got the word result as the column name. If I want additional columns, I then put in a comma and then the new second column. So 3 plus 3, result 2. Now you may have noticed I haven't put in the word as. Now the word as in SQL Server version of T-SQL, the code language that we're using, is optional. You don't use it. You don't actually need it. But for me, I do use it because it makes the resulting code so much clearer. So I use as every time, but it's down to you. You can use whichever you wish. So I'll execute this. And there we go. We can now see we've got 2 columns. So I'm going to add even more code. I'm going to say 4 plus 4 as result 3. And execute this. And we have a third. Oh, we don't have a third column. What's the message? Incorrect syntax near 3. And you can also see a little red squiggly underline. The computer is saying, I have no idea what you're talking about. And the reason for this is the computer does not like spaces being put into column names unless they are surrounded by hard brackets. So here is the result with the hard brackets around, and I've just pressed F5 to execute. Now another thing you can do is add in carriage returns. So this is a perfectly valid result, a perfectly valid select statement. So I can execute that and get the same result. You can go to some extreme if you want. Again, this perfectly valid. You could have a carriage return before the comma as well. And in fact, in more advanced SQL Server code, there is some nice reason why having carriage returns before commas, so like this, is actually advantageous to you. So this might look odd, but later on in more advanced code, that is actually a useful technique. Now, I talked about this being Microsoft's version. Now, Microsoft's version of SQL is not the only SQL that's available. There are others like Oracle SQL, and that's quite a major competitor, in fact. Now, why do I bring this up at this stage? Well, firstly, this code would not work in Oracle SQL. And the reason for that is in Microsoft's version, the select clause is the only one that's mandatory. It's the only clause in the select statement that you absolutely need. In Oracle's version of SQL, you do need the next clause, a from clause. Second, a lot of the Oracle variants require words like select to be in capital letters. Now you can have it in capital letters if you want, or you can have it in lowercase, or you could have it in a variety. It's entirely down to you. And thirdly, Oracle's version requires, to a large extent, semicolons at the end of sentences, at the end of statements. So the select statement is a statement made of a select clause, a from clause, and others. It's only at the end, when you've reached the end of the sentence, the statement, that you would then need the semicolon. Here in Microsoft's version, the semicolon is optional. There are only a very few limited instances where it is actually needed. Again, that's quite advanced. Now, here's the code, and let's say I wanted to copy this code to Microsoft Excel. Well, I can do this by clicking on this top left-hand button, and I could just copy, Control and C. And if I copy and paste into Excel, then I get the data. If I wanted the headers, then instead of just clicking on there, I'll right and click on there and go copy with headers. And now I've got the headers as well. And usually that's the one I use. So this is the select clause. The select clause is the equivalent of print. Now you'll notice that in this video we've not actually retrieved any of the rows from the transactions table. That's because to do that we need one more clause, the from clause, which we'll have a look at in the next video. Now in this video we're going to add to the select clause by adding the from clause. So what I'm going to do is get rid of this semicolon, press carriage return and type the word from. Well, you can see the red squiggly underline is back. What SQL Server is now expecting is the name of a table. And so what I'm going to do is I'm going to drag dbo.transactions from the Object Explorer into my query window. So there is our select statement with a from clause as well. So let's execute that and we'll see that there are 8,845 rows. Success! Except each row contains the numbers 2, 6 and 8. It's not actually retrieving any data from SQL, from the transactions database, the transactions table. So why is that? Well, because we've got the columns that we just invented. So what I'm going to do is I'm going to delete all of these fields I've previously put in and instead put in an asterisk or star. So select star, and I'll just change this so that it's all of the same case. Select star from dbo.transactions. Now what the star does is say, I want to retrieve all of the columns. And we can tell what columns there are by clicking on this plus next to this particular table. And then click on the next plus next to columns. So execute. And there we have our data that we've previously put in. Now, if you don't want all of these columns, then you have to get rid of the star and start again. So that's the case even if you've got, say, 20 columns and you wanted 19 of them. So you have to list the ones you want, not the ones you don't want. So I want purchase order ID, comma, quantity ID, and product ID. Okay, let's execute that. And we've got 1, 2, 3 columns and 1, 2, where's the third column? Well, there was a missing comma in what I've put in. And so what it has done is it's treated that as saying, give me the order quantity, but let's call it product ID. So this is a real way, a real reason for having the as. If I have it in every single query, then I know that I'm not going to have these little problems. At least it reduces the likelihood. Now, it's not the case that you have to drag things, you could type. So if I start typing, you can see that the computer tries to auto-complete it, or at least give some suggestions. So purchase order ID after just 2 characters is a suggestion. So I'm going to use the arrow keys to get to purchase order ID and press the tab key, and that auto-completes it. So if I execute that, we've now just got the 1 column. Now, I'm not just limited to running one query at once. I could have multiple queries. So select the unit price from dbo.transactions, for instance. And if I execute that, we now have the results of 2 queries, one underneath each other. And you can see the total 17,690 rows is exactly double the number of rows that we've got. First time it's giving us the purchase order ID, the second time it's giving us unit price. So we've now combined the select clause with the from clause, and we can add as many different columns as we want and execute that. So what we're going to do in the next video is we're going to create another table, and we're going to combine this with this existing query. What I want is a description of this particular item. So it's fine knowing that it's product ID 1, but what is it in reality? So that's in the next video. So in this video, we're going to create another table and we're going to use the sheet 2 information here. So it gives us the product ID, which is the same product ID that we've previously been using in the transactions, and the name, and where applicable, the color. So let's create a new table. Hopefully you know how to do this before I even mention it, and you know what to do now. So we have to type in the column names. Now, just one word of warning. I generally avoid having a column name called name. I find it not that useful, especially when we're going to be looking at multiple tables. For instance, we've got a transaction, we might have a product, we might have a customer name, then we might have a location name. There's probably lots of different names. So if you're using SQL Server, I would say don't call something just name. Have it a bit more of a descriptive name. Now, what is the data types? Well, these are integers, just like our previous version. Now, these are text, so I use varchars for this. It's a bit of a complicated subject why I use varchars. And the number that's in the bracket tells me the longest number of characters I'm allowed. So I'm going to have 50 characters, which is enough for what I want. So I'm going to change that for color as well. So I'm now going to save this as a product table. Notice it doesn't appear in the Object Explorer. I need to refresh. So let's populate it. So I select everything and I paste. And it's just 504 rows. It will be done very quickly. Hopefully you're as a dab hand at this, you know exactly how to do all of this. So what I want now to have is the product name. So I can go select star from dbo.product. Oh, there's a squiggly underline. Why is this? Well, it's a bit like the refresh. Every time we add a new table, query, procedure, the autocomplete, the IntelliSense over here, doesn't realize that it's been added. And what we need to do is refresh the IntelliSense. And we do that by going to Edit, IntelliSense, Refresh Local Cache. In reality, I just press Ctrl and Shift and R, but this is the way to actually find this refresh. And in a few seconds, this squiggly red line disappears. Right, so now let's execute. And we can see we've got two different results here. We've got the transactions table and we've got the product. Now what I want is to have the product name up here in the transactions table. And I do this as part of the from clause. Now this is probably the most complicated part of this particular course. What I need to do is create a join. So let's just map it out in terms of what we've got. We've got a table, transactions table, which includes the columns, purchase order, ID, order quantity, product ID, unit price, and line total. And we've got this product table with product ID, product name, and color. And what we're saying is, I would like in this table here, I want an extra column of product name. I want this to go essentially here. So we need a way to link from one table to the other. Now to do this, what we need to have is a field which is the same in both tables. And you can see that the field which is the same is product ID. So there is my join. Any rows in table transaction and any rows on product ID, on the table product, where the product ID is the same, where they are equal, that is where my connection should be. So how do we write this? So select star from dbo.transactions, join dbo.product. So there is this arrow, there's your join. But what do we join it on? We join it on the transactions field. So where the transactions product ID is equal to the product ID. So let's execute that, see what happens. And now you can see we have got just one result table, 8,845 rows. And we have our first table here when we're using select star. So here's the 5 columns from table transactions and the 3 columns from table product. Now, of course, this is a bit unwieldy. We can simplify this by using the word as. So I want, instead of dbo.transactions, I want to just call it as T. And instead of dbo product, I just want it to be called P. So now we are joining T, or we have the table T, and we're joining table P on T.product ID equals P.product ID. And you'll often see tables being represented by just 1 or 2 characters in SQL Server code. So just as we use the as in the select clause to rename our columns, we can also use it in the from clause to rename our tables. Now, just one word of warning, and this is where it might get a bit complicated. This only works where every single one of these product IDs in table transaction has got an equivalent in the table product. If there was one that didn't, say I had this as product ID 10,000, then it wouldn't, this row would not get returned because there would be no equivalent of product 10,000 in here. So if I wanted to guarantee that every single row of my transaction table would be returned, plus any additional data in the table product, then instead of using the word join, I would use left join. So it goes from my first table, all of the rows guaranteed, and any additional data in table product. In this particular example, we have the totality of data already, so we don't need that. So what I might do now is just reduce the number of columns that I'm seeing. So I want purchase order ID, order quantity, product ID, unit price, line number, so line total, and the product name. I don't need to have product ID twice. I could add in the color as well, maybe. Okay, so I'll execute that. And ambiguous column name. So what's that talking about? Well, it's because we have a product ID in the table transactions and a product ID in the table product. And even though we know that they're equal, the computer wants you to specify which one we're talking about. Well, I want the one in the table transactions. The table transactions we've now redefined as table T, so I'll just need to put T dot at the beginning. That's all it needs. And you only need to do that where there's an ambiguous column names, an ambiguity. You can put it in even when there isn't, if you think that will make things clearer. So now if I execute, we now have the 5 columns from table transactions and 2 additional columns from table product. So these joins, as I say, probably the most complicated part of this particular course. Don't worry if you haven't quite got it. We'll be progressing onto other clauses, and that's all you need to know about this join. So in this video, we have completed our look at the from clause. And next, well, we've got 8,845 rows. Is there a way of reducing that? Say I wanted to search for a particular set of rows. Well, we can do that in the next video. Now, in this video, I'm just going to go back to, at the beginning anyway, a slightly easier version of our SQL query. So this retrieves 8,845 rows. But suppose I wanted only those rows where the purchase order ID was equal to 8. Well, that's almost exactly what I write. The third clause is where. So where the purchase order ID is equal to 8. So let's execute that, and you can see that the where reduces the number of rows. It doesn't reduce the number of columns. That's done in the select clause. But the where reduces the number of rows. Suppose I wanted all of the purchase IDs between 5 and 9. That's literally what I write. Or suppose I want it where it is less than 10. So as long as you're aware that this is the less than sign, and this is the more than sign, and you can add an equals. So at the moment, this isn't giving us purchase ID number 10 because 10 is not greater than 10, but I could say is equal to or greater than 10, then you'll be fine. Now suppose I wanted the purchase orders 1 and 8. Well, I can say where the purchase ID equals 1 or purchase ID equals 8. Note, I'm not saying where the purchase ID is equal to 1 or where the purchase ID is equal to 8. Only one where clause needed. That's one way. Another way is saying where the purchase ID in open brackets 1, 8. So if I was doing this in plain English, I would say where the purchase ID is in 1, 8, but you don't use the is in this particular instance. So both of those will work. Now let's go back to our product table. So select star from dbo.product. I want all of these products where the color is black. So where color equals black, and execute. And unfortunately, the computer is thinking that when I say black, I'm talking about a previously unknown column. I'm not. I want the literal, I want the text called black. Okay, well, if this was any other programming language, I would add double quotation marks to refer to this as speech, if this was Excel, say. But that doesn't work either. What I do instead is have single quotation marks. Now, I should point out, on some versions of SQL Server, you may find the double quotation marks actually working. In reality, the majority of the time, double quotation marks work the same as these hard brackets. So, where color is equal to black, there we go. Let's narrow it down a bit more. I want where the product name contains the word black. So if I just change that to product name, it will give me 0 rows because there is no product name called black. Instead, I want the word black to appear anywhere in the product name. Now, if I was using Windows Explorer, I could use a wildcard of a star to mean 0 or more characters. However, this isn't the case in SQL Server. Instead, I use the percentage sign. So what this code says is where the product name equals any number of characters, including 0 characters, then black, and then any number of characters. So it could be black bike, or it could be bike which is black, or it could be bike which is black and white. So if I execute that, oh, still not working. Because again, we're not telling the computer that these percentage signs are wildcards to be used. So instead of using the word equals, we use the word like, where the product name is like percentage black percentage. So that gives us all of the answers, including, you'll notice right at the top, one row where the color is not actually black. It's just in the product name. So just to make a note, percentage equals 0 or more characters. Now the computer has underlined this in red because it thinks that this is code. Now to say that it is a comment only, I put 2 hyphens at the beginning, and you can see it turns it into green. So it ignores any lines with these 2 hyphens. So let's go back to our more complicated example and say I want to have all of this data, but only where the color is equal to black. So where the color, can you finish it off? Color, like, apostrophe, single quotation marks, percentage, black, percentage, and single close mark. Will that work? Because it's a lowercase b and we're using uppercase b's here. And the answer is, it depends. It depends on how your database has been set up. The default for new databases in my version is what's called case insensitive. In other words, this will work. But if you had a case sensitive version, then it would need a capital B at the beginning. But usually databases are set up for case insensitive. So you could use small case b, you could use an uppercase black. It would return the same results. And you notice that is also giving us silver stroke black because I've used the where, the like. If I wanted to be just black, then I would use the equal sign without any of the percentage signs. So in this video, we've had a look at the where clause. We've had a look at using greater than, less than, equal to, and we've had a look at the word like. And we've also had a look at the word in and the word or. And just like we use the word or, so where product name is equal to this, or where product name is equal to something else. So that would return both black and silver, or both black or silver. We can also use ands, we can use nots, we can use other things. If you are used to using them in Excel, you can fairly well use them here with some modifications. Now in the previous videos, we've created tables, we've added data, we've retrieved it, we've reduced the number of columns, we've reduced the number of rows, but it's all been very literal. We've not actually done any analysis. So for instance, I've not tried to work out what the total cost of purchase order ID 7 is. It's just literally retrieving all of the information that I gave. So let's try to do that. So I'm going to start from my simple select star from dbo.transactions. And what I want is the purchase order ID, and I want the line total. Okay, and I execute that. And incidentally, that's one reason why I do generally start from, I select star from and set up my tables, because when I go back to select clause, then the autocomplete works. So there is again my original data. It's not totaled them up, it's just retrieved the data that I want. Now if you're used to Excel, you know that you could put the word sum around your particular field. So here we have sum, open bracket, line total, close bracket. So let's execute that, and we will find, for instance, for purchase order ID, we have a total of about 41,000. So job done, go on to the next video, and oh, okay, let's find out what this error message is all about. The purchase order ID column, that's this one, is invalid in the select list. Oh my goodness, does that mean we can't use it? Because it is not contained in either an aggregate function. What's an aggregate function? These are things that summarize, like sum, count, min, max. So it's not an aggregate function. Well, we don't want it to be an aggregate function. It would look particularly odd if we try to total up the order IDs. I want order ID 7. I don't want order ID 21. I don't want to have to sum the 7s. Or the group by clause. And this is the fourth clause of the select statement. So if you're doing any sort of reductions in terms of aggregation, sum, count, min, max, if you've got any other columns, and you generally will, you need to use the two words group by and put any additional columns in the group by. So let's execute that. And there we can see that the 8,865 rows, 8,845 rows have been reduced to 4,012 rows. Now I'm going to add a where to this, where the purchase order ID is equal to 7. So we can see now the total 58,685. Does that sound right? So we're going to just do our original query. So we've got 14,000, 25,000, 18,000. So yes, add it up, 14, 32, 20, 32, 58, 57, 58. So yeah, 58,000 sounds about right. You notice that this new column is called no column name. So if you're using an aggregate function, it's generally good form to put in a new name. And of course, if you're using spaces, then you must use hard brackets. Now you'll notice that in the earlier query we did not include a where clause. And that's actually quite deliberate, because a select clause is absolutely needed. A from clause is needed if you're going to refer to tables. The where clause is optional. The group by is optional unless you're using aggregations. And what should you do if you're not using aggregations? I generally don't use the group by clause. It's only to be used if you want to reduce duplications, for instance, which is a possible function of the group by clause. So there will only ever be in this result set one row with purchase order ID 7. So we've grouped all of the remaining data for purchase order ID onto one row. So let's go back to our more complicated query. If I wanted to have the total cost of all of the different colors. So I wanted a line that said how many dollars black items were sold for, how many brown items, how many blue items. I can do that. Well, first of all, there's a lot of columns here. I just want the color and I want the line total. So let's start with that. So execute that. So that still gives me 431 rows, that being the total number of black colors in here. So I'll just get rid of that and have it the lot there, 8,845. So now I want to aggregate them. I want to collapse them. So there's only one black line, one silver line, and so forth. So I will group by color and I will sum the line total. So there's my line total. So now you can see we have reduced the number of rows to just 10. Silver, grey, red, blank, multi-black, blue, yellow, white, and silver stroke black. So group by. It's used whenever you are doing an aggregation, sum, count, min, max. Generally, you won't use it otherwise. And you can use it with a where clause, or you can use it without a where clause. The fifth clause is not often used, and it's called having. What would we use having for? Okay, we have in our previous video done this select statement. So we have grouped all of these purchase orders. Now I don't want to see all of these. I want to see only the big ones. I want to see where this total of line total, I want to see where that is more than $50,000. If I said where line total is greater than $50,000, then what that would do is that would look at the original data. So I would put a filter on this original data and say where the line total is greater than 50,000. So you'll see, if I just highlight these two, it's only giving me 10 rows. If I remove this filter, you'll see that purchase order ID 4007 actually contains in itself 9 rows. It's just that only 3 of them have got an individual line total of greater than 50,000. So it would exclude all the others. But that's not what I want. I want those purchase orders where the total of the line total is 50,000 or more. In other words, I want it to be done after this group by analysis. And that's the difference between the where and the having. The where does it on the individual rows before the group by, and the having does it on the results after the group by. So having the total of line total greater than 50,000. So let's execute that. And you can see there's a problem. And it's a bit of an odd problem because you'd think that the computer would know about total of line total by now, but it doesn't. There's a bit of a complicated reason for that. You can't use a alias from the select clause here in the having clause, even though it looks like you should be able to. So what I've got to do is, instead of using total of line total, I've got to use sum, open bracket, line total, even though that looks like the same thing. That's the version that will work for me. So that reduces our, 4,000 rows, 4,012 rows, down to just 295. And if I were to find the purchase order 4007, then it would not just contain these 3 rows total, it would contain the total of all of these rows. So the having happens after the group by. So fairly rare to use the having, much more common to use the where. The 6th and final of these select clauses that we'll be looking at? Well, this is all over the place. These purchase orders are not in the right order. We can order it using the word order by. So I want this query to be ordered by the purchase order ID. So if I execute that, now you can see it's in the right order. And now I can easily scroll to purchase order ID 4007. And we can see that the total is 554020, which is the totality of all of these particular rows. So they're having worked. Now, order by doesn't necessarily need to be from A to Z, A to Z in ascending order. It could be in descending order, and for that we use DESC, descending. So there we can see it's going from 4012 down to 7. So we've had a look at all of these clauses. Now, if you were going for a job interview, as I said previously, it may be the case that you've got to just write your select query on a piece of paper or in a Word document without access to SSMS. And one of the things that an interviewer would be looking for is to make sure that you've got these clauses in the right order. If you've got them in the wrong order, that's a certain sign that you are new to SQL Server. That's bad. So how can I ensure that I get it in the right order? And this is quite easy if you're using an English keyboard or Spanish keyboard, because if I just get an on-screen keyboard, let's have a look. If I just put the word where in here, so where product ID greater than 1, let's say, to give all 6 clauses. Let's take the first letter of each of these and see where they are on the keyboard. S, F, W, G, H, O. With just one exception, we start with select and we work left to right. Select from, group by, having, order by. The one exception is where, and we have to remember that that's third after select from where, group by, having, order by. So if you've got an English keyboard in front of you, then you automatically know the order. It just goes from left to right with just one exception. Now this works on an English keyboard, American keyboard, Spanish keyboard. It might not work on others. If you're using the QWERTY keyboard system, then it should work. So this is a really top tip if you are going in for a job interview, or if you're just trying to show people that you are familiar with SQL. It is a rookie's mistake to get these 6 clauses in the wrong order. But now you won't, because you just look down at your keyboard and remember the right order. Select from where, group by, having, and order by. And that is the select statement. Obviously, there's a lot more detail that we can go into, but this is as far as we need to go in this introductory course. Now, as you might imagine, this code can get really, really complicated very quickly. How can we save it? Well, we could literally just save it. It becomes an SQL file, which in reality is no more than a glorified text file. You could open it in Notepad, and then you can open it for later use. But what if you wanted to save it within the database as opposed to an external text document? Well, we can do that with the views section. So all views they are select statements. Nothing more, nothing less. So I'm going to create a new view. So this view, my first view, as. And it's all we need to do. So create view, give the view a name and say as, and execute. There we go, command completed successfully. So how can we retrieve that information? Well, first of all, we can refresh our Object Explorer. We can see the My First. So what do I want to retrieve? If I want to retrieve the results of that view, then I can say select star from My First. So there's my first view. So I execute that, there's results. But suppose I wanted to retrieve the actual SQL code. Then I can right and click on it and go to script view as, and I can use create, drop, select. Drop means delete, by the way. Select. So if I select 2, you can see that it is telling me what the actual select statement is to get the information back. But if I want what the view is, the sum, all of the warts and all, then I go to select view, create to new query window, and that gives me the text exactly as I had put it in. So there is a difference you can see between select to, which just writes a select statement that I wrote earlier, and create to, which gives me the exact text of the view. Just one note about views. If I was to try and put this into a view, it wouldn't work. Not as is. So create view, my second view as, execute. And the reason why is the order by clause can't be used in views. There is some exceptions, but won't go into them here. So I just need to remove that. I'll just comment it out by putting 2 hyphens at the beginning. I can also press this button here, comment out, and now I can create my view. So to retrieve that, I can go select star from my second view, and then I can say order by and whatever I want to order by. So order by purchase order ID. And you see all the red squiggly underlines. We need to refresh the local cache. So that's one way of saving. The technical name is encapsulating a previously written select statement. Another is by creating a procedure. So instead of saying create view, we say create prog. Prog is procedure. So create prog my first, so where's my first prog as, and that's all we need. Now to execute procedures, we don't say select star from my first procedure. Instead, we just say execute my first procedure. So we can use exec, or we can use the word execute, or we could take the word execute out altogether and just say the name of the stored procedure. And that will run the results. So that will run, in this case, the select statement. Now, an advantage of a procedure is we can have more than one select statement in it. So create prog my second procedure as, I'll put this order by back because I'm allowed to do this. I'm allowed to have order bys in procedures. So now I've got 2 bits of code in this procedure. It's going to be a simple select from a particular table and then a very simple select statement. So now I've done that, refresh. If I execute my second procedure, you can see that we have 2 queries being retrieved. And again, if I want the original code, I go to script, create to my query editor window. And that's the exact code that I put in. So 2 words to encapsulate this, either in views or in procedures. Now let's end this section by exporting the results of a procedure. So let's say this my first procedure and the results of a view into Excel. So what we could do is just literally copy and paste like we have done in the previous video. But suppose we wanted to create a connection from SQL Server into Excel. What's the advantage of a connection over copying and pasting? The advantage is we can refresh the connection. So if the data changes, we can have the latest data in Excel just by clicking refresh rather than having to do all the copying and pasting again. So let's create a connection. So I'm going to create a completely blank spreadsheet and I'm going to go into data and I'm going to get data from a database, from an SQL Server database. Now this version of Excel that I'm using is Excel 2019. If you have an earlier version of Excel, you may have a slightly different set of menu options. For instance, this is what it looks like in Excel 2016. I would still go to the data tab and I would click on from other sources, so get external data from other sources, and I would then go to SQL Server. So let's get information from SQL Server database, and the first thing it asks is, okay, where is your SQL Server database? It's just there. Well, you can't do that. Instead, what I'm going to do is I'm going back to the Object Explorer. I'm going to click Connect, Database Engine, and I'm going to copy this server name. You may, of course, have credentials from your system administrator. And then the name of the database, well, I might as well put that in as well. Name of the database is my first database. So to get the name, I'll right and click on it, go to rename, just allows me to copy and paste. So it says what credentials shall I use? Well, I'll use my standard Windows credentials. So I'll click connect. Again, if you're using an earlier version of Excel, what you're seeing might be slightly different. So I'm going to use an unencrypted connection because this is literally on my computer. So what I'm going to get is a view. So I can get my first view and you can see a preview of what that looks like. So what I've now got is my view and I'm going to load this data into Excel. So I just need to give it a minute or two, getting the data, and there's the data. So the great thing about this is that whenever the data changes, I can just click refresh. In the table tools design, I have to actually be in the table to refresh, and it will refresh the data. It will re-query SQL Server and get the very latest, and that saves an awful lot of time if all of your data is stored in SQL Server. So that's a way of getting tables and queries. But what about getting procedures? Well, almost exactly the same. So I'm going to get data from database, from SQL Server database. Again, I need the name of the server, so I'll just copy that. And I'll need, in this case, the name of the database, so my first database. But now I click on Advanced Options, and this is where I can type in my SQL Server statement. So my advice, if you're doing this, is to create your SQL Server statement. So it could be a store procedure, or you could be creating your own custom select statement. So if I just do a very quick one here, so select star from table transactions where the purchase order ID is less than 10. So just write your select statement in SSMS, execute it, make sure it works, and then copy the code. Don't copy the results, but copy the code into Excel and then click OK. And there's your answer. Similarly, if I was creating a connection to a database, stored procedure, exactly the same thing. So I need the database name if I'm using SQL code or stored procedure, and I just get my execute. And that's all I need. So that creates my connection. So if ever the data changes, I can just refresh and my Excel data becomes the most recent. So this is how you can connect SQL Server as the back end to Excel as the front end.
Thank you for watching this video. If you want to learn more about SQL Server, then please check out the link below. A special offer is included. Now, as you can imagine, there's only so much I can fit into an hour's course. In my full course, which is only around $10 if you use this link, we'll go into depth in SQL Server. There'll be plenty of quizzes as we go along, so you can be sure that you're learning. And there's a 30-day money-back guarantee, so you've got nothing to lose. In other courses, I also cover the other components of SQL Server: database administration, SSIS, SSAS, and SSRS. Have you got any comments about this video? I do follow the comments, so please let me know how you found this video and what topics you want me to cover in future videos. Thank you very much, and I hope to see you in my Udemy courses.